welcome guys. We're getting towards the end of this learning segment, and I'm going to write in this name up top here. And this name is Definitely Googleable. That's right, Jackson Pollock. Google that guy, check out what comes up. He is an artist. Oh, yes, you Googled it, you've seen it, you found it. Artist, very, very interesting art and usage of color and usage of dripping paint. And his art looks a little messy, but people find it quite beautiful. And believe it or not, he can sell those paintings for a whole lot of money. Maybe that came up when you Googled it. So anyways, the reason why I put it up today is because you are going to make today a Pollock. You're going to make a Pollock-like painting, and not a painting, right? You're going to want to have lots of colors out, so have at least 4 colors out, maybe more like 5 or 6, we'll see. And on your grid here, we're going to really fill up this grid. We're really going to fill up the United Nations to the rescue. So this is our culminating activity for the chapter, where you've studied a lot, done a lot of linear inequalities, done nonlinear inequalities, and then of course systems of inequalities. We're going to use a whole bunch of constraints to help solve a more complex problem where you're limited in more ways than 2 or 3 or so, which is about as many ways we've been limited so far this chapter. So it'll be a lot more than that. And with all those colors you'll be using, you're going to have kind of like a Pollock-like painting at the ends. And hey, maybe you'll be able to sell that painting for about as much money as Jackson Pollock's been able to sell his paintings for. Jackson Pollock's dead too, by the way, so he's no longer making money from his paintings. But hey, other people are making money. Those collectors, man, they really rake it in. Anyways, let's get into it today. The final assignments of the chapter, applying inequalities to solve problems. Take it away. So it says here, today you will pull together all the mathematics you have studied in this chapter and applied to solve an application problem. Very nice. United Nations to the rescue. Remember, this is kind of the premise of the chapter is that, hey, the United Nations, right, has a lot of constraints and limitations. We're limited in the world by various factors. And they need to take all that in consideration and help make better decisions for the countries that are part of the United Nations. And therefore, the world is better off here if we understand constraints. As a representative of your country, you've been sent the following letter from the UN to give an important task. Dear representative of the United Nations, a critical matter has come to the attention of the United Nations. In the past, when a catastrophe struck in a part of the world, the UN gathered supplies to give to people in need. Unfortunately, because the UN had to collect supplies from each country at the time of the catastrophe, it was always quite a few days before the supplies could be sent to the areas that needed them most. A recommendation has come before the UN to create a supply of food and medicine packages for future emergencies. And wow, is that ever relevant right now? How can we plan? We get these supplies, get these resources, right? Get them in place so that we can actually distribute them, what is possible later. Each food package will be able to feed several hundred people, while each medicine package will supply 1 first aid station. I'm asking each country to donate the same number of packages so each country shares the burden equally. Well, that's not really sharing the burden equally, right? If America gives the same amount of packages as like Haiti or like a smaller country, I don't know why I said Haiti, a tiny country. Lithuania, right, is pretty small, I think, or Luxembourg's even smaller. That wouldn't really be fair, right? So it should really be based on size of country. But anyways, the premise of the problem is just going to be that same number of packages that each country is given. I'm asking each country to determine how many food and medicine packages they are able to give. Oh, okay, cool. So trying to spread the burden around there by figuring out what you're able to give. You will present your findings at today's United Nations meeting. Please be certain to use the information that your country's budget committee has prepared to help you decide how many packages you can afford. Best of luck, and may our efforts make our world a better place. Hooray! Sincerely, the Secretary of the United Nations. United Nations. It's Secretary General, by the way. Secretary General, I believe, is Ban Ki-moon from South Korea, is the Secretary General of the United Nations. Pretty important position there. After consulting with your country's budget committee, your teacher will supply you with some information that will help decide how many food and medicine packets your country can afford. So that's what you're doing today. Hopefully you read through it on your own. Maybe forward through my reading of it, because hey, you have this information here. So your teacher has already given this to you. This is the information. Normally, this would be kind of one of those card sort assignments where everybody at the table is holding one of the countries, and then you have some communal countries here, and you got to work together to solve this constraints problem. But I think you can just, if I just give you all this information, you can do this on your own. So it says here, your task to communicate your country's budget constraints. Write an inequality expressing how many food and medicine packages your country is able to give. Let X equal the number of food packages, and let Y equal the number of medicine packages. And then on the lesson resource page provided by teacher, graph the solution region representing the number of medicine and food packets that can be donated by your country. Be prepared to share your graph with the other countries of the United Nations. Okay, so it looks like here on this page here, what you're going to do is to write an inequality, a Y and X inequality, how Y relates to X in terms of the constraints presented, because it sounds like the constraints are going to be based on number of food packages and number of medicine packages, and they're probably going to be related to one another. So I won't continue writing Y and X in case I'm wrong about that. So you're going to write the constraints here, and then when you have the constraints, you're also going to graph this out. This is what they're talking about towards the end of the problem here, is that you have to graph the solution region representing the number of medicine food packets that can be donated by your country. So for each of these, so it looks like we might want to have 6 colors for this. 1, 2, 3, 4, 5, 6 to get the 5 countries plus the special assignment, so that we have 6 solution regions on this graph, and then we can start talking about what's the feasible region, what is the appropriate combinations of food packages and medicine packages that each and every country would be able to provide. And again, that would be a little unfair, because if your country can provide a lot of both, right, you probably should just provide a lot of both. But if it's everybody's giving the same, then hey, you've lucked out. You're a wealthier country. How dare you? Anyway, so we're doing that now. All right, so let's check it out. Hopefully you do this on your own. You're mostly just checking your answers by doing it with me. But I just want to make sure you have the answers. That's why I'm filming this video, to give you guys closure on this. If you had trouble on this, or even if you didn't have trouble, if you're just checking your answers afterwards, you can kind of do it along with me now. So let's get started on country A. Let's see what it says here. Because we're spending so much money on improving our hospitals right now, our funds are very limited. We are constrained to spending up to, but no more than, $300,000. Each food package will cost our country $900, and each medicine package will cost $600. So this is practice with word problems, it looks like. And when we see the word each, or every, that should jump out to you, okay? This is one thing I really tried to impress upon you in chapter 2, that when we see each, or every, or per, it refers to kind of a rate of something. That's a rate. And a rate in math is a change number, right? Is a slope, okay? Is a slope. So when we see that each food package will cost our country $900, then we got to take that $900 and put it in front of X. Put it in front of X, because for every time X goes up by 1, that's one more food package. It costs $900. And then we also have Y here. Every single time Y goes up by 1, Y is the number of medicine packages. Every single time medicine packages goes up by 1, you got to pay $600 more. So 600Y plus 900Y would represent the total amount that a country would spend. This country A, would spend, given how many food and medicine packages that they need to create. They also say they're constrained because they can't spend any more. They can't allocate this in their budget. They can't spend any more than $300,000. So now I want to put $300,000 this way, because I think you get the idea. We can't exceed the $300,000. This can't exceed this. So which one needs to be bigger? $300,000, does that need to be bigger than whatever they're spending? Or is that bigger than $300,000? Well, I'm hoping you chose this. I'm hoping you pointed the inequality symbol towards 300,000. So I know that can be kind of confusing, because you don't want to exceed 300,000. But what this is telling us is that 300,000, that's going to be larger than, right? Larger than or equal to, right? It says up to is kind of an indication this is going to be inclusive. And says no more than, well, that's going to be this greater than symbol, because it can't be any more than what's on the right side. This needs to be bigger than the right side, so this can't be any more than the left side. There is one inequality. So let's actually just do them one at a time, kind of graph them out as we do this. So let's graph that out on our graph sheet here. So first one that I'm gonna do is and I'll write this a little bit differently so we see it maybe how you wrote it on the other side. 600, or maybe I'll do 900x plus 600y is greater than or equal to, is less than. Can't be up to 300,000, needs to be bigger than that. So let's graph that. That'll be our blue graph. So to do that, let's get borderline. Let's get our intercepts. I know what you're thinking. Hey, this is standard form. AX plus BY is equal to C, right? If we're doing the borderline. So then we need to graph intercepts. So here, let's start with our y-intercept because we can actually get that. So I got X and I got Y here. Y-intercept is going to be the value of Y when X equals 0. So 900 times 0, that's just 0. And then I have 600 times Y brings us to 300,000. So 600 goes into 300,000. Well, 600 would go into 300 a half time. So it'd be half of 1,000, or it'd be 500 if you're doing your head. So 500, and you can check here too, our axes are set up for us. Only goes up to 500 there, so it must be that. And it doesn't go to 500 in this direction. So our y-intercept is going to be way up here at 500 for our country A border. So we have my y-intercept. Let's get our x-intercept. So this is going to be if y were 0 here. Now we have 900x. So 900 doesn't go quite into 300,000 quite perfectly, but we have a decimal. So if you do that, just do it in the calculator. 300,000 divided by 900, you should have gotten 333 and a third. 333 and a third. So we can just kind of estimate here. It's not going to be perfect. And again, this is going to look kind of like a Jackson Pollock. So we don't want it to look perfect. We want to sell it for lots of money. So this is going up by tens here. So this is 300, 310, 320, 330. So right here.
The x-intercept.
And here is where we're going to draw our border. So you want to have a long ruler. I don't have one with me, so I'm going to have to improvise with a sheet of paper. But I'm going to draw my border. Wait, hold on a second. Is it going to be solid or is it going to be dashed? Oh, that's an inclusive symbol. So it's going to be in solid because the borderline will be included in the solution for country A. Okay, so they can't exceed this, and that means we're going to shade below. We're going to shade below because 0, 0, we're going to do it in a second. 0, 0 is definitely a solution to this inequality. Okay, there's our borderline. Didn't have a ruler, so it looks kind of messy here. And maybe I'll label it country A. And 0, 0, is that a solution to this? Yeah, 0 plus 0, that's less than 300,000 for sure. So here, let's shade it in. This is what's possible so far for all countries, right? Because this is possible for country A. So this is what we're starting with. So our feasible region is going to be lower than this once we add on more inequalities. So that's one color down. So I'm going to throw the blue away. We have 4 countries left. And then we have one other special assignment constraint. So try to have 5 other colors handy, right? Try to have 5 other colors handy. Because this is going to get messy. These linear programming, otherwise known as systems of inequality problems, they can get pretty complex. And they can get pretty complex pretty quickly. And now my camera's in focus. We're going to learn more now about this situation. Let's look at country B. We got country B. B for beautiful. Beautiful country. Maybe it's America. America the beautiful. And I'll use orange for this one here. So let's get this out of the way. All right, what are we saying here? America. Because we're spending so much money on improving our schools right now. Yeah, right, America. This does not sound like America at all. Maybe we'll go with Belgium here. Our funds are very limited. We are constrained to spending no more than $600,000 total. Each food package will cost our country $500, and each medicine package will cost $2,000. All right, got our there, 500 for food packages, and that's X. Every single time we get one more X, we cost $500. One more Y is going to cost $2,000, and then we can't spend any more than $600,000. So it's okay if this whole expression over here equals $600,000, but this can't be beyond $600,000. So I'm going to point it this way. Right, so we're going to point at where the number is, the large number, because we can't go up to that. We're constrained to this. We're limited by this. We got $600,000, so this needs to be less than $600,000. So we have that written there. So let's get this graphed out. Let's do it over here I'll put B here, B for beautiful. And I'll write it differently. 500x plus 2,000 is less than 600,000. This just makes more sense to me because the whole, we want to be constrained by it. You want to have less than $600,000 spent at the end of the day. So intercepts, let's get them going. Both are going to go into 600,000. That's nice. X and Y. X-intercept, value of X when Y equals 0. So Y is going to be, I missed my Y there. If Y is 0, that makes this a zero product. So 500X would equal 600,000 on the borderline. And that would be what? 1,200. So it looks like we're actually going to go off the x-axis here. 1,200, that's a pretty big x-intercept. So we might have another way to solve this. Okay, y-intercept here. Y is going to be much smaller because it's $2,000 for each medicine package. Medicine costs a lot in this country. Jeez. So 600,000 divided by 2,000 would be 300. You can only have 300 medicine packages if you produced no food in that country. That's a much easier y-intercept to find, and that's what we find on the side here. So let's get it graphed. We have the 300 here, and this is 1,200. I'm going to do an alternative way of graphing this one, and that is through slope. Slope here, we're going from 300 to 1,200. Our change in y is 300, so I'd have to go down 300, and then over 1,200 for slope. So what would my slope ratio be? Let's do it. Change in y over change in x would be, well, if it go down by 300, our x would increase by 1,200, and that would just be 300 over 1,200 is, right, 1 over 4. 3 over 12 is 1 over 4. So it should be negative too because y goes down. So to graph this is how I graph this. I just graph it using slope at this point, and slope would be down 1, 2, 3, 4, and over, slope is down 1 and over 4. Rise over run. Rise -1, run 1, 2, 3, 4. And so on and so forth. And this would probably be the easiest way to graph this because the intercept is too far. Right? Through 2 points, make a line. So you can really use any of these 2 points to graph it through. And I'm going to stop because this looks like this is going to be a key point in the feasible region potentially. Right? As of now, it's in the feasible region. Maybe it won't be later. And it says no more than, so it was less than or equal to, because it can be exactly 600,000 spent. So this line represents $600,000 spent. You spent all the money that this country is willing to give to this UN. That would be this line. But they could also give less, right? So if other countries are only willing to give less, then they would meet them down below. So here we're starting to see a potential feasible region. And we're limited by all less than inequalities right now, so it's all down below. 2 markers down, throw it away, and we have 4 colors to go. So this is going to get messy. Hopefully you have this so far, but this is it. Balancing all information, using tools like graphs to help balance information, and keeping the eyes on the prize of us humans. We know what we want to find the answer to. We know we have machines and other systems that will help us get there. But that's what makes a human, is that we know we have problems to solve. And although we can get help through stuff like graphs, through computers, we ultimately got to figure out what is it we're trying to solve. Remember how it all kind of ties together. That's what our jobs are as humans here. Here we go. Memo foam country C. Let's go with Canada. Why not? We were just talking about America the Beautiful. Let's talk about America's hat, which is known as Canada. Since our country is doing so well financially, our citizens voted that we must spend more than $540,000 in aid to other countries. Each food package will cost our country $2,000. Each medicine package will cost $3,000. Well, this does sound like Canada. They're so friendly up there, eh? They like to give. They're not exactly this whole like uber capitalist, I'm only looking out for myself type thing that America's got going on. They want to give back sometimes, or at least that's the reputation. Anyways, they want to spend more than $540,000. So here I'm going to write the money part first of what they're spending. So we're going to take $2,000 and $2,000 per food package, and then we add in the medicine packages. And they want to spend more, right? It wants to be pointed away from the $540,000 because they need to spend more money than that. X and Y, oops, sorry, this should have been Y here. X and Y together, they want to get more. They want to buy more stuff, and then so this needs to exceed the 540,000. That's what they're hoping. So they want to spend more than that. So I'm going to cross out the bottom because they don't want to spend exactly 540,000. They more than is non-inclusive. They don't want to just spend $540,000. They want to spend more than that. So let's get that graphed out. Let's do that here. So I didn't label. Make sure, because they might want to know this later in the problem. This was country B here. Now we're moving on to country C. And we'll do that up top to organize this here. Country C. And this one here, our equation was this. So let's get our intercepts. X, 2,000 is going to go into 540,000. We basically have to take 540 and divide it by 2. And that would be 270 would be our x-intercept. Y-intercept, we got 3,000. And that will also go into 540. So we need to take 54, divide it by 3, and that would be 18. 18. So 180 medicine packages is the minimum, right? The minimum they want to create. So remember, this is a greater than. So we're gonna shade above. We're gonna shade above this constraint line, and so that's why these intercepts are a little bit smaller here, or at least this one's a lot smaller, the x-intercept. So 270 is our x-intercepts. Let me go down to this here. And then the y-intercept is up here at 180. And there we go. Graph it on out. Graph the borderline. So this is representing all of the values. That would be exactly 540,000. Remember, I'm doing this dashed. This should be dashed for an A plus paper, because they don't want to spend exactly 540,000. They want to spend more than that. And where is more than that? Oh, right, up here. We buy more. We're spending more than $500,000. So I'm going to shade it in. Is this looking like those Jackson Pollock paintings that you looked at the beginning? Whew, man, this is crazy looking. This is nuts. This is really tough. Let me do that much. So where are we looking at here? Are we okay here? Was everything covered? No, this is just blue and black. We don't have orange. Here, this is looking pretty good, blue, black, and orange. So it's looking like this isn't included in the orange. This is a part of the orange, not part of the blue. So it's looking like our potential feasible region right now is this side. This would be a side, a constraint that would win over the other ones. And then here, and then here. So it's looking like it's a 1, 2, 3, 4, 5. Looks like it's a crazy looking pentagon shape right now, thus far, where this isn't included, right? Because it doesn't include the black. It's above the line, okay? So this is looking pretty crazy, man. This is looking at that freaking art that we can sell for so much money. Because Jackson Pollock, ooh, man, his art looks pretty crazy looking like this. And boy, does that ever sell for oh so much money. Anywho, learn about art here in math class. I don't know. What else is there to learn about? Since our country is doing so well financially, our citizens voted that we must spend more than $900,000 to aid. Okay, so it's another one. We just did that one, did we? That was D. So here's where we're becoming organized. Oh, this one, D is doing well too. Never mind. D is another one where they're doing very well. So I'll see if I can do this. We're getting pretty up there. I'll see if it's in green. Want to spend more than, so again, we're going to be more than 900,000. So start with the 900,000. And more than is going to be this. Okay, so also going to be non-inclusive. And we got 5,000 for food plus 2,000 for the medicine package. And I know you see where it's going with this here. So let's just do it on here to save some time. We got X here, we got Y here. How many times is 5,000 going to go into 900,000? Well, how many times does 5 go into 900? Because these are all in thousands. Okay, we have 900,000s here and 5,000s here. So what does 5 go into 900? 180 times. So 180 is the x-intercept. And the y-intercept, well, 2 goes into 9. Oh, that's a little bit trickier here. So how many times does 2 go into 900? And it would. So this would be 450. So they can do 450. And they want to do at least 450. So this is a greater than symbol. More than. They don't want to just do at least. They want to do more than. So again, we'll have a non-inclusive border here. Okay, and this is country D. So country D, we're looking for intercepts. 180 for X. I'm going to put that here. A lot of information, right? Math, a lot of times, you're just balancing and figuring out how to work through information. So that's what you're getting practice with in school. border, our intercepts right here, and we're gonna graph the borderline and then shade above it, because again, they're doing so well, they want to help. They want to allocate resources. The unfortunate thing is that that means that pushes other countries to the max of the resources that they're able to give. So they really should just give more than those other countries, but hey, that wouldn't be a good math problem. Okay, shade it in. This doesn't matter up here because we're above, but this matters up here because now we're below the orange, and now we're below the blue, so this is looking pretty good. And yes, this is super messy. It's going to be hard to find what the solution region is, but hopefully you find it. Hopefully you get there. 2 more to go. Country E. Country E. Oh, we didn't actually label what we just did for blue or for green, but that was D. And black we didn't do either. That was C. So I'm trying to keep them organized in case we have more questions to answer. Country E says, luckily our country has many medical supplies. So there's no limit, wow, to the number of medicine packets we can offer. However, due to the farming restrictions in our country, we are constrained to donating fewer than 250 food packages. So the medicine packets don't matter, but X, which is the food variable, they have less than, they have fewer than 250. They can't give exactly 250, so that means they give 249 and below. So anyways, I think that's non-inclusive at 250. That's kind of what the problem is implying. So we have a point. So let's see, is our borderline, is that going to be vertical or horizontal? Well, what's X equals 250? Well, let's go to our intercept at 250 right here. Okay, that would be a vertical line. So our border would be a vertical line here. And this is out of ink. I'm going to do this in gray. We got country E right here. And this would be the border. And we need it doesn't matter how much medicine to give. They have lots of medicine. So we can go up here to infinity, but we just go down here to get our answer. And oh man, is this ever looking like a Jackson Pollock? This is pretty crazy, keeping all this in. So that's just going to break apart. Our solution region is going to be below, right? Got to be less than here. So that's going to form kind of a border here, it looks like. It looks like all the other ones go up to this. And we have some other points kind of restricting it. We're going to draw it in at the end. Last thing, last one, special assignment. What color haven't I used yet? Color blue it is. It says, we are expecting food shortages in the near future because of the severe drought in Sudan. Each country must give at least 100 food packages. So that means that X needs to be greater than or equal to 100. At least means it can be 100. That's fine. You can do something, give more if you can. That's going to be our final. So this is going to be the special assignment. Is this, and I'll have a dash line right here. And we shade above. And we shade above. Normally when I do this in class, honestly, we take up almost an entire whiteboard doing this. So we can see it a lot more clearly. And then you guys hopefully appreciate how when you have tons of information, it's hard to kind of organize it. Let's see if you got the answer. Let's see if you got it correctly. I'm going to shade where I see the answer here. And this is tough. So the green line, right, we want to start with one of the lines here. Remember, we need to be beyond this green line. And it looks like that's the beginning here of this, is that we shaded, so green line we shaded above, and the black line we also shaded above here. So we need to be careful with this. These are the ones that were greater than constraints. And then there was another greater than constraint here. So I'm going to put the dash line here because this looks like it's going to be one of the original, right? It needs to be above this amount. So here, and then it looks like the blue line comes in. We need everything below the blue line. The blue line here is below the orange line, so we don't need to worry about it. It's also below, yeah, I don't know. I can't really tell what's going on. But I believe this is it, right? This is the one we just put in the special assignment. And then the blue line looks like it's also going to be a border. So country B, below that, we were above C, above D, below country A, and then I'll draw this here down like this. And Is this the answer? Is this our feasible region? Well, let's see. Let me just double check that I found the feasible region correctly. Here, special assignment, we needed to be above that. Yes, this is all points are above that. C, remember that was one where the country was doing well on C. Right, doing well, so we had a greater than symbol here. We wanted to spend more than the borderline. And so, yes, we are above C. And then with country D, that was another, we're doing well. D for Deutschland, I guess. The D, it's above the line there, so that's good. We haven't violated any constraints yet. Country E, I did not label, but that was in one where we needed to be below. We were constrained to be less than. Oops, yes, I made a mistake right here. We needed to be cut off. We couldn't be this. This is incorrect over here. We needed to be like this. So this is not a quadrilateral, it looks like. It looks like a pentagon, where we have our feasible region. Cut off there. So that's country E. We need to be less than 250 food packages. Couldn't do more than that. And then we needed to be more for the special assignment, more than 100 food packages. And this is it. So I'm pretty confident on this. I think I'm going to lock this in. You might want to go through, if you're on a test, you go through it 1 or 2 more times. So I'm going to lock this in that I believe this is our final answer. The feasible region that countries can give any combination, all countries, right, based on those 6 constraints, can give any combinations of these coordinates. So if they wanted to give 200 food packages and 150, they'd be allowed to do that. That wouldn't be violating any of the country level constraints, nor would it be violating the special assignment constraints. So let's see here. We do all this work. We find that. Are there going to be questions to follow up on this one? Sure as heck, be sure of that. There are definitely questions on how we apply this. Okay, so let's apply this together here. Question 912. As a member of the United Nations, you must consider each of the following proposals. In each case, assume the United Nations would like to receive as many emergency supplies as possible while still having each nation give equally. One proposal is to have each country give 185 medicine packages. How many food packages should the United Nations require from each country in this case? Explain how you made your decision. So remember from the original part of the problem, they wanted people to give as many emergency supplies as possible. Well, it's still giving equally. So we're not going to violate the constraints, but we want to maximize out those constraints. Okay, so one proposal is 185 medicine packages. And here's how we can use this information here. We can go to 185 on our y-axis, so that would be right here. Right here. And if we go across there at y equals 185, we want to max out the food because we want to max out the amount that we're giving people away. So it looks like it's about over here, down here. Looks like we should, if you gave out 185 food packages, every country would still be able to give 200 food packages if you gave out 185 medical supplies without violating any of the constraints. So that is, again, located right here on the graph. 185 and 200 is on the border of the feasible region. So the border of the feasible region is showing you this is where it ends. The constraint needs to keep you within the feasible region, so this is as far as you can go. So over here, you've maxed out the amount of food you can give. So this answer here would be 200. And you'd have to say something about that because it is at the furthest right edge of feasible region when y equals 185. Another proposal here. All right, let's talk about this. Another proposal here is to get the largest number of medicine packages possible. What is the largest number of medicine packages that each country can offer? How do you find this answer? So most amount of medicine packages. So we want to look at our y-axis. We want to go to our highest y value, right? If we had a ruler here, for instance, we could just go up and be like, at what point is y maxed out and we're still in the feasible region somewhere? Are we right here? So if we had 250, could we have more than 250? Well, yeah, you have the food options here, but you have a whole bunch of options. Here at 270, okay, we still have some food options here. Can we go a little bit higher? Yeah, it looks like we can go a little bit higher. So it looks like the maximum you at 280 is the most medicine packages you can offer. Okay, so 280 medicine packages. And at that level, you can actually figure out how much food you'd have to give in order to satisfy all constraints. So if you gave 280 medicine packages, you'd only give out, I think, 70 food packages, but 280 medicine packages. And what we did is we found the top value, and it actually happened to be a corner, right? In economics, you're often looking at the corners of the feasible regions because that's usually your maximum value choices that you can make. The top value or the corner there of the feasible region. We know it's possible. We know it's the highest amount within a feasible region. Extension here, I have a last-minute proposal suggests balancing the number of food and medicine packages. For instance, if a country gives 150 food packages, then they would also have to give 150 medicine packages. How many food and medicine packages should the United Nations require from each country in this case? Explain how you determined your solution. Okay, so I think what it's getting at there is there's actually a line we could draw on this, which would show all the options we have where we have the same number of food packages, a same number of medicine packages. And what line would that be, actually? What line? Well, I'll show you the line. This would be the line, okay? For instance, here, the point of this line would be 50-50. Does that in the feasible region? No, but that would be the same amount of food packages to medicine packages. 100, 100. That's a point on the line. So we could draw a line like this through the feasible region. And this line actually has an equation. What is this equation? Well, y just equals x, right? If y is 50, x is 50, this would be the line y equals x. So I can draw that line in just so you can see. I'm done with my Jackson Pollock at this point. Hopefully I'm not ruining the value of this painting by putting, or this drawing, by putting this line in here. These would be all the values within the feasible region that would be equal in terms of number of food packages and number of medicine packages. So the United Nations could choose any of these values, right? Any of the coordinates here, and the countries would be able to provide those. So let's see. Let's make sure we just answer the question here. 150 and 150, are they able to do that? 150 is a point on this line, and it's also in the feasible region. 150 is definitely an option that the countries could do. It says here, how many food and medicine packages should the United Nations require from each country in this case? Explain how you determine your solution. Okay, so they, again, want to max out. So let's go to the highest value that's in the feasible region, and that looks like about 210 or so, or 200. Yeah, it looks like 200 to me. Yeah, 200. 200 would be right here. So this would max it out. 200 food packages and 200 medicine packages would be on that border. So we've maxed out. We've moved, we've shifted things to maximize all of the resources we can use, but still staying within the constraints. So 200 food and 200 medicine. And my justification is it's the last point on line y equals x that is still on the right, I'll put upper right, upper right border of the feasible region. And upper right border is important for the feasible region because that means we're looking this way, because this upper right means a lot of medicine, the higher we get, and the more food, the further right we get. And that would be the best we can do. All right, guys, I got into that one, and most importantly, I have a piece of artwork to put up on the auction blocks, and hopefully I make a lot of money, and I will not be teaching next year, right? Because I'm just going to retire young because I got my Jackson Pollock fake. Don't act like, I might as well autograph it here while I'm at it. I think I get paid more. This is clearly a Jackson Pollock because it's autographed by him, right?